Hello, I'm Chris. This is Gross Models, and welcome to this build of the Inventor series, the Acebot Quadruped Bionic Spider Robot. This is going to be quite a quick build, I think. There's not too much to the build. A lot of it's based on the programming side of things again. So we'll see how it goes. It's Wi-Fi and app controlled, structure building, action design, programming, learning for ages 8+. So I should be okay. We'll see how we go. I have opened it up, but I haven't really done anything with it. But let's start off by having a look at what's involved in the kit, what's included in the kit, and we'll go from there. The main page obviously is the same as the front cover. The contents are quite easy. Basically, we've got lots of servos. That's almost it. We've got 8 of these servo packs, which we've got the little manipulator bits on the top. 8 of those, 2, 3, 4, 5, 6, 7, 8 of them. There we go. We have a little USB-C cable. Everything seems to be going USB-C, which is good. I quite like it. The one thing that wasn't included in the kit is power. I've picked up a couple of the can't remember the number of them now. The normal batteries, 18650. That's the ones. These are rechargeable lithium-ion batteries. These ones are actually chargeable through USB-C. Plug in USB-C directly into the top there. Power them that way. Little LEDs come up on the top to tell you when it's charging or when it's charged. So they should be okay. Only need 1 for the kit, but I got to get rid of it to 2. So they are there for, well, towards the end. Also in the kit, we've got other things. What have we got in here? We'll get everything out and then we'll have a good look at everything as well. A screwdriver, some cable ties, Acebot sticker. We've got a couple of boards and all of the connection pieces. Got all manner of spacers, screws, bolts. No washers to speak of, but there you go. All of these nicely labelled, so they're easy to tell what's what. That's that. We've got the 2 electronic board pieces. Let's get those open and see what we've got here. The biggest one is this one, which contains the battery socket and 8 jumpers. This is where the main body of it, if you like, which is there. The other little one here is the main controller board. Just torn that open, and it hasn't actually opened. Great. That open so we can see what we're doing in there. This is the main electronic heart of the beast, which is an ESP. Oh, it's got numbers on there, but it doesn't mean anything to me. That's the spider shield. So this is the main guts of the beast. That's where the USB-C charging comes in. Connection comes in. That is going to sit on top of there. Way around. I don't know which way around, but we'll figure that out as we build. So that's the difficult stuff. The only other thing that we've got in here is the bag of all the other bits. The actual mechanical building part of the kit. Pretty much 3D printed by the looks of it. Anything to do with it, but we'll get it out the packet anyway. See, there's no tiny little bits that should be involved in there. No, there's nothing. Get rid of that. We've got multiple parts that all seem to be the same. Those, and we've got these corner pieces. 4 of those, 1 big board and 1 other shaped board. Now the entire course for this is online. There's QR codes and things to sign, scan and get into. I did have trouble downloading it. The computer didn't want to download it because it said it was potentially a virus. but I have managed to download the PDF file. So I'll get on with it and we'll have a look through and see what's what. What I am going to do first is peel off all of these backings from all of this. When I built my 3D printer back in the day, I completely forgot. I didn't realise that it had basically this coloured paper over it protecting it. So my 3D printer has mostly still got the covers all over it. But I shall get these removed and then have a look and show you the online version, the PDF bit of it. All of these little bits. So yeah, let me clear this all up and we'll see what it looks like. Okay, so here we have the online sort of side of things. The Acebot manual, the Quadruped Bionic Spider Robot tutorial. This I have downloaded. We've got a bit of that company. So let's follow us on Facebook and YouTube. So we've got several sections to do on here. We've got six sections. Software, assemble, and then set it all up and teach you how to go forward and backward, left and right, dance, and Wi-Fi control. There's an app as well as being controlled through the board. So first one, lesson 1, software installation and hardware understanding. I like a bit of understanding. Right, we mainly use Acecode as the programming software. Acecode is graphical programming software. It allows you to use the program by simply dragging and dropping blocks without needing to master complex programming languages. That's useful for me. I like not having to master things. So using Acecode, write the program code, then upload it to the controller board. Okay, I have downloaded and installed it. Done that. Version 2 and about, yes, it's the most recent one that I've got. Anyway, that's okay. Installation method, I've installed it. I've completed the setup of it. Find the shortcut to it on the desktop. Click to open the Acecode. I already have it running here. This is the Acecode, and the lesson 1 I've loaded up on it already. So let's see what it has to say. Installed around a Mac. No, I don't need to do that because I've got a Windows PC. So if you want to install it under Mac, you can do that from there as well. All complete. OS, Mac OS, Mac OS. Hardware knowledge. Right, the ESP8266 is the board that we've got in this kit. It has several different connections to it, which are all visible on the board, on the picture on the screen there, which I shall put on the screen there. Acebot brand. It's quite nice. It's not a nothing company, this. So that is what we've got there. Lots of inputs and outputs and things. After installing Acecode, you can use a simple program to test whether the development environment is successfully built. Follow the steps below. Connect the motherboard to the computer. That will be using cable provided. Let me move things out of the way. Get the cable done. I have got my extendable USB socket somewhere up here. Have it here. Where is it? Lost it. Right, let me figure out where I can plug this in. I'll plug it in through the USB socket. I've got one down here. One I was planning on using, but there you go. There you go. That's one end of that plugged into the computer. The other end I shall plug into here. Being USB-C, it doesn't matter which way around it goes. Little bleep and a little flash of things. So that's doing something. Select upload mode, ESP8266. Let's get the software up and running again. Not connected. Install serial driver. Let's make sure we've got that installed. There we go. Device updated. Yeah, you can use that. Install. Right, let's get that installed. Pre-installed in advance, apparently. Okay. Good. Then we connect that on COM3. It says connected. Let's go back to there. I wanted running. Right, let's back to the screen and see what we've got. That's now connected on COM 3. That is the board. 82, whatever it said. Good stuff there. Then let's move that out of the way. Click the connection button. Done that. COM port. Connect it. Upload the code, and you can see it. Output. It says fail to connect to Wi-Fi, but that's okay. Upload mode. There we go. Upload. There's an upload button. Upload progress. A little while for it to upload, but there you go. Yes, I'll let that do that. That's fine. Windows firewall. Files. Installing everything to begin with, I think. I should have probably done that before I started recording. But there we go. 99%. Go right into Flash. Good. I like the software. It's got a good sort of serial monitor down there. I'd normally have to open up and do. Okay. 99% still. Writing. Dot, 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 dot. 32%. Flash complete. Flash complete. Hello. It's printing hello once every second, just like what it said it should. There we go. So let me just change that. I can edit that. Yes, I can. Let's change that to the traditional Hello World. And upload that. Should go through quicker this time round. Writing. Takes it a minute for it to do that, but that's okay. So on here, I can see what it's doing. It's quite faint on there, but it is doing stuff. Generated. Include Arduino H. Void setup, serial begin, that, and what we're printing. And that's that. That's everything that we got on there. So that now should be saying hello world. It's not. I clicked a thing. I must have clicked away from it. Let me not click manual editing. Might have broken it. Might have changed it. I changed it and sort of should have made things work, but I might have broken it. I shouldn't have changed it. Start the program. Forever do this. Wait a second, and it loops it. I understand the theory behind it. I don't understand the coding. There we go. Flash complete once again. I think I broke it by changing the thing. Yeah, I thought I could figure it out. I thought I knew what I was doing. Let me clicking buttons now. Video is built into it. That's quite good. Move and stay. It's teaching you how to do everything. But what I am going to do is close that all down. And I shall figure out what's what and come back and hopefully explain it to you. Right, yes. I figured out. I figured out what I did wrong. What I did wrong while I was editing and putting that, changing the text in there, I grabbed this and pulled it out from there. So the file that it was writing didn't have anything in it. Whereas if that connects back in there, it adds it in to actually do the printing. So that's, yeah, this is how it's built. It's built out of little blocks that you plug in and can change the things in there. So I can change that to 5 seconds, for instance. I'll get rid of these remarks because we don't need them on there. Let's upload that and check to see that it prints hello world once every 5 seconds this time. So yes, we've got this was a forever is a repeat, and you've got to repeat 10 times. Like different controls that you can put into it. Repeat until something, wait until something, if and else, Windows. I understand all this. It makes sense. And you just plug it into the jigsaw piece and make it do what you want it to do. So let's just check to make sure that works. Let's flush complete. Loading, and every 5 seconds, hello world. There you go. 1, 2, 3, 4, 5. Hello world. Good. Right, that makes sense to me. I understand how it works, which is all I really need to do on these. So, yeah, that's running on that board. Doing itself, it's just connected up for power and to transmit the data back to the computer saying, hello world, but it could equally be doing lots of other things. So, yeah, I understand that. I get that, and I like it. Good. Let's go back to this. So we've done that. Yeah. Know the servo extension board. Servo expansion board is mainly used to connect 8 servos. Under the control of this, drive the servos complete different actions. Following points you've noticed. Connect the controller board. Pay attention to the USB port and the switch on the same side. That tells me which way around to do it. Charging mode. After connecting the battery and turning the switch to off, connect the USB charging cable and expansion board. Use mode, put the switch to on. So let's go back down here and see what we've got. We'll unplug that for now. This is the board that we're talking about. This is the switch, which has got 2 positions. It's off and obviously on. So that's that. Okay. Yeah, so it's just understanding this particular board. Got positive and negative connections. Orange data line for servo, which is the 3 connections on each of these. The servo we need to understand. Let's get a servo open. Servo, each pack seems to be identical. It's got connections and screws in there. The servo itself is a little motor that just goes to a set point and stops there, or it will go 280 degrees or something around. We've got 3 wires. We've got ground, positive, and signal. So that's telling us all about that. Yeah. Telling us how to connect it up. If I go back to the screen there. So yes, programming interface. We've got to plug this onto there. So we plug the board onto there, giving the USB the same end as the switch. All of these pins need to line up and go into place. Along there. That will go home to there. Nice. I like that. I understand that. Now the servo goes into the first one of these with the orange on the inside. That is our first servo connected up. Right. Column with the red arrow. Signal line of the servo. Servo drive steps. Right. 1.2 servo. Connect the board with the USB cable. Switch the upload mode. Servo board. Upload the code, and we'll see what happens. Switch it off. And put it to on. Right. Let me dig out the code, install it, and we'll see what it looks like. Right. I had a couple of bits of problems, but I've sorted it out. I'll show you exactly what the problem was in a sec. I plugged in the servo onto here, just like it showed, and uploaded the software and everything, and it didn't do anything. But I'll show you why, what I know, and what I've done to change it. You may notice there is something different between my programming over there and their programming there. It is the servo bit. I've changed this from 4. I changed it to 4 because, according to this picture here, the 0 is the one down the bottom here. Then we've got 1, 2, 4. And on the other side, we've got 6, 7, sorry, 8, 7, 6, and 5. I'm not entirely certain where all the numbering things. There's a set of pins not attached on there, which I would assume would be 3. I don't really know, but it worked. So I changed that to 4. I didn't change the others, but I probably should as well. Let's change that to 4 and that to 4 as well. I shall then turn this to off. Back at the bench, I've connected that to that one, which is 4. Plug that in. All the lights come on. Not connected, so I'll connect that and upload it. While I'm uploading that, I shall show you the other problem I had. I'll put the battery in. It was too long. It wouldn't fit. These connections were quite bendy, and quite stiff actually, and very proud. So I've actually had to adapt those to make the battery fit. But the battery's gone in and it makes contact, so I'm sure that is okay. That is now going through there. We've got a little flashy light down there, which you maybe just be able to see, saying that it's getting data. When that finishes getting the data, it goes to a solid light. Then we can unplug that, like so. Then when I flick that on, the servo will do things. What I will do is just attach to it so you can see it do things. There we go. It goes back, it goes forward, goes back, and it flicks back to there. I've tried 2 servos because I was trying to figure out if the servo was broken or it wasn't working. But they do exactly the same thing. So I'm fairly confident that they're all okay. I will test them all to make sure that's okay before I go to the next step. And the next step is zeroing all of the servos. After that, it says, open 1.3, 0, connect it, upload the code to the board. And then we get to do the whole assembling the robot bit. So, that's going to be the bit that's going to be fun. I'm going to look forward to that. But for now, I'm going to test all these servos, make sure they all work, and see if I can learn a little bit from the zero code. But I'll figure out that first and show you that before we get into the building. Okay, before we get to the building, I plugged in all of the servos and just randomly picked number 7 to test out to make sure that it connects up as I thought it did. And when I turn that on, it does indeed do the things that it should be doing. So, I'm happy that that is working as intended. I've tested all of the servos. They're all working as intended. And I know where the plugs go on all of that. So that's that. I've also, you may have not have noticed, taken the matte backing off of that. I've left those on. I'm not sure if they're meant to come off or not, but I quite like them on there like that. I picked off the bits from the inside of letters and indeed picked up all the bits off there. So we've got lots of shiny black left over there. I've got one packet of those open, the rest of those not open. Sure, we'll be using probably only one of these. They come as a pack with all the different types and bits cut off, so you haven't to cut it down yourself. But so I shall put this away for now and get the actual building done of the kit. I'll show you the instructions and then show you the build step by step. Right, first thing before the actual build, the Zero program. I've loaded it up and installed it and run it. And I think I understand the programming of it. It basically is setting all the servos to the correct positions, depending on where they are. It's just running the Zero program, and it's defining the Zero program here, setting 0 to 45, 1 to 135, 45, and setting them all to the right angles for how they should be set up. So that makes sense to me. What I will have a look at in the corner here is the code itself. See if we understand this right. So we've got the Arduino library and the board library. We're calling the servos the right things depending on where they're put in. Makes sense. Defining the blocks, we're telling them where to run to. 5 4 to the right things. And then the void running is I don't know about the timer. Just set a timer to make sure it works, I assume. Activate it and then call my blocks and runs it to 0. I understand the programming apart from the allocate timer command, but that's obviously just set pin 4 setting it to the bit that we wanted to call it. Yeah, I vaguely sort of understand that. Right, that's the programming out of the way for now. Let's get to the building. Right, so we've got the list of structural parts, acrylic board, and screwdrivers, and pins and everything. I didn't see any of those. They in a different bit. Wait, one sec. How many of these should I have? 8 of those. Got 8 of those. Got 4 of those. I haven't got some bits. Right. Right, I shall. Oh, no, they're all those bits. I do seem to have the tibias missing, which are probably the feet bits. Right, I'm going to check to see that's building up that bit. Yeah, I'm missing some parts. Right, I shall contact them and see about getting those parts and then see what happens from there on out. Okay, I have rummaged everywhere and I can't find the claw pieces, the feet. So I've made some. I know I did have them, so it's not a case of not being in the pack. I'm sure they were. I do remember seeing them, but I don't know what happened to them after I was sorting out all the bits. So I have used some plastic card to make up some bits. They're not quite as thick as these, but they're almost there. And they're obviously a different colour and not quite as shaped or as nicely made, but they will perfectly do the job. If I did want to spend some more time, I could get them all filed down, shaped, and nicely made. But I'm pretty sure that they will do the job as intended, and it makes it hybrid and more of my own piece rather than just stock building. So I'm happy with that. That's okay. I've basically cut them out to a rough sort of shape of that. I've made them the right size for the servos to fit into as they have to, and drilled some holes for the bolts to fit through as well. So yeah, they're similar to exactly the same in function and similar in look. So we'll be using those momentarily. But first of all, we're going to fit the circuit to the frame, which just goes on there like that. We need what's that? We need 4 M310. We need those M3 nuts. I probably need those. No, we won't need them. M310. There we go. Plates and brackets. So we need 4 of those and 4 of the posts. 2, 3, 4. Just get out what you need. Leave the rest in the bag so you know exactly what they are. Save them getting mixed up. Oh, there was actually one of those. There's 9 of those in the pack instead of the 8. So one in case you break it, by the looks of it. Often you get a spare of things. In fact, there's 5 of these posts. I'm sure there's going to be a few extra screws as well. So yeah, there we go. So that's the spare one of them. I'll put that over there. These are going through the bottom of that plate and through this into a post like that on the 4 corners. Put the opposite one in next just to make sure everything lines up as it should. Hole there for it. There it is. Try that again, shall we? Put that through there, into that. Right, so I get the other 2 of those put in. Then we need to affix servos to the outside of this. They will all go in. The servo posts to the outside. So that one's going in there that way. That one's going in there that way. On the other side as well. And we're using nuts and bolts to hold that together as well. Let's dig out the bolts we need for that. They are M214. M214, that's those. And some M2 nuts. So let me get all of those on, get the servos onto there, and then we'll see about the fun stuff. Actually, then it says to put the board on, but I've already put the board on, so that's okay. So I'll get that built up, and then we'll see about the interesting bits. Okay, so starting building the legs. I built one, so I know what I'm doing as much as I ever know what I'm doing. So we need to, first of all, open up one of these packs from the servos. Need some bits from that. What we need is not those bits, not that screw yet. I shall put that with the other two. We do need that and those two. We're going to be attaching this to this. It goes on that way round. The screw goes through the top of that into there. This is the easy bit. That goes in there. That one goes on the other side. Hold our servo arm onto this. Just like that, nice and secure. Bit tighter than that to hold that in there. Go. So that's that on there. Then we need to make up our shoulder joint, which we do through here with 2 nuts and 2 of the bigger bolts. So the nut is held that elbow join. That goes over the top that way. This is going to be the same as the one that I've already built, and then we need to do 2 in the opposite orientation. That goes in there into the nut. That holds that secure like that. That one goes on same on the opposite side. Like so. That one through that way. We need another pack of servo bits. I've already got one ready, but there we go. Get rid of that. We need the same bit, those bits, and not that screw. That is attached to, again, the inside, that joint. Like so. Don't need that yet. That one in there. Okay. So these servo joints, tighten those up again, are designed to fit onto the top of the servo. Knurled, they fit on in multiple different positions, so that just fits on like that. The other screw that I'm not using goes through the top there to hold that tight, but we can't put that on tight because we don't know exactly where that position is going to be as yet. We've got 2 other things to do with servos. So first thing is going to be attaching this one. No, sorry, the servo's already attached to the frame there, so that's where the top one of those goes onto. What I do need to do is wire this up. This one goes to the inside there, like that. This one will go onto the outside there when that's attached to the outside of the leg. But the first tricky bit is my new thing needs to be attached to that that way round, I believe. Let me double check. And a few pages. That many pages. Yes. I need 2 that way round and 2 that way round, basically, for different feet. Now, the trouble I have with this is getting the bolt through there was easy. Trick is getting the nut on the other end, because it's very close to the body of the servo. So I found the best way of doing that was to have that done up yet. That off. Pull that back down through there. So it's basically flush to the top of the claw piece. Slide that onto the top of it, then tighten it up. But it's fiddly. It's tricky. It's a pain in the backside, basically. It took me ages to get the first one attached, and even then, I had it attached the wrong way round. That is there, I think. Looks about right, but it's not tightening up properly, so it might be cross-threaded a little bit. But yeah, anyway, that needs to go on there. The other bolt, the other side with the other nut on there. Then that goes onto one bit of that, facing basically downwards. And then that goes onto the other. I think that'll be on that corner. I think I've done that one onto the wrong one. And the other two that go the other way. Now, to connect it up, I've already loaded up the Zero program onto this, which I shall show you in a moment over there. And when you turn it on, it basically jerks the servos and puts them in the correct positions for the Zero position, which I believe is there. That means then I can tighten that up on there. So, for instance, this one will now be zeroed. So if I had that on the wrong place, like that, when it zeroes, it wouldn't be there. You can't just shift it, because servos they're not like motors that just keep going round and round. They have a particular position, and they'll only go so far in either direction. So that you would need to make sure is there, although, as I say, this is actually going onto the top one there. The other ones will have the fork going in the opposite direction, and the claw indeed going in the opposite direction as well. So this is going to be pointing downwards. So I'll get the other ones done, and then I'll show you the Zero code as well. So I shall see you in a little while, but for you, it will be no time at all. Right, that's all of them attached. Not screwed in place yet, because I need to adjust them. Like this one is slightly that way. So what I need to do is pull it off on the right position. Actually, I think that's probably the closest position anyway. No, that's probably better. That will go on there. So if I do flick it on, I've got the Zero program on it. So when I turn it on, they all wiggle and they all line up. No, that's definitely better the other way around. A little bit of tweaking to get those in the right places. That one that's not quite right, I think. But I do still need to do the same with them. That's the closest to straight, which isn't quite straight, but I can't do anything about that. I'll try loosening these off and see if I can adjust it a little bit one way or the other. It needs to do the same thing with the up and down on them. So this one is probably a little bit too far down. So I'll play around with that by, again, disconnecting these from there. Trying it on in different positions to see if I can get them. Yeah, that's better. That's just square like that. That one's square. That one is about as square as it's going to get. And that one is up a little bit, but again, I think it's as close as they're going to get. So I'll put these screws in to hold all those servos correct. We need to tidy up these wires, which are what the zip tie is for. Let's get those move it out the way a little bit. Make a little bundle of those, and then the plate goes over the top onto the tops of those. Hold it all looking nice. That's 4 of those screws to do that. So let me get all the screws in, get that on, get the plate on, and then we can have a look more at the programming again. So there we go, all installed, all set up. I've installed the Zero program, so when you turn it on, it wobbles and sets itself in place. And that is the build completed. The cables are all tidied under there with enough to move. They don't move very much, very fast, so you could probably get more of that tucked away under there anyway. But I'm happy with how that is. Battery installed in there, and all the servos connected. So other than that, that is the building side of things completed. You can still get to the plug in there to connect it up for programming, which I do still need to do. So let's go back to the main screen. We'll have a look here. We've got the pin numbers for everything. So we've got the expansion board. Well, we've got 0, 1, 2, 3, 4, 5, 6, 7, and 8, which are the left and right, lower and upper arms and paws, as are shown on that diagram there, and indeed on my model. So the motion of the servo, the right upper paw, the larger the angle, the more the servo moves up. So make it move down towards the ground by changing that. So yeah, right. So the basic controls of the robot include forward, backwards, left, right rotation. I don't know if it can also shimmy left and right. I suppose you could probably you'd have to get the alternate legs to work in to do that. So yeah, we'll figure that out. I've added the extension to the software as it says to do it, and then we can install the standby mode program. State of preparation before the robot does other actions. So and it should make it look a bit like that. So I've got the program in here. It's just a little bit because we've got the quadruped bionic spider robot set of instructions, and we've just got standby mode. We could have laying, sleep, greet, or any of those things as well. We'll try in a minute and see. But what I shall do is make sure that's connected to the board and press the upload button. And we'll upload it all just the same as normal, copies it all across for extra files, packages and stuff. When that is uploaded, when it goes to 100%, all variables all done, it just says 99. Don't know if it ever goes to 100. Oh yeah, writing now. There we go, that's writing all the flash. So once that's done that, you can't see the little flashy lights on the board. So you can if you look for on the edge there, a little flashy light in there, just flashing blue, showing that it's actually picking up information. That has now finished. It's gone solid blue. So I can unplug that. And then when I turn it on, it should go into rest mode. It's done things. It's sitting there, sort of breathing a bit. It's a little bit creepy, but also quite lovely. So yeah, all of the legs are sort of working. The ankle, the body piece is directed out to the X formation, and they're doing the breathing motion. They do actually sort of slide over the surface a little bit, which is good because I did round them when I made them. So I'm quite happy with that. Quite like that. So if I turn it off now, it will just stay in whatever position it's in at the moment, which that's a better position than the rest mode anyway. What I will do is plug it back in, make sure it's connected again. Let's go back to the screen, and I will change this from standby to we do. I'll just do handsome. I've got no idea what handsome mode would be. So let's upload handsome mode. And we'll see exactly what that does for itself. I've got no notion as to what that would be. So it's writing it in. Taking a little bit less time to write because most of the files are obviously uploaded to it now and it knows about that. So we'll let that continue to write everything. ... Final page of dots appearing, 99%. That gets to 100%. Flash complete. 100%. And yeah, solid blue light. So I can unplug that. And we'll turn it on and see what do we think handsome mode's going to do. Okay, it's a little program of sort of presenting himself. Work better without the. I think he's turning himself round as well. Short to tell when it's on a bridged mat. Yeah, that's quite interesting, quite different. So yeah, let me turn that back off again. Oh, no, I'll wait till he's back up standing straight again. There we go. Yeah, so that was handsome mode, but obviously I can play around with the different modes and things. Before we go back to looking at what the next thing is, it's teaching us about moving forward. There's obviously a plug-in that says move front. After uploading the program, it found the arm pause on the diagonal side do the same action. Yeah, so that's how it would walk front and back. What have we got? So if it's going that way, these two will move in sequence. Sort of forward, take the weight, and then those two will move forward to take the weight. That makes sense to me as to how it should walk. And move backwards is basically the same again. Arm and diagonal side of the robot do that as well. Extending tasks. We'll get it walking first and see what that does and how that looks. Right, I have uploaded the forward and the back programs to them separately, and it is doing what I would expect it to do. Combination of putting the forward down and up down, and got the wait command in there as well, so it's still doing that, but it's moving and then waiting, moving and then waiting. Take out the wait command, it would obviously just keep moving all the time. So it's good, and I understand the programming behind it. What else is there in this section? We've got left and right and clockwise and counterclockwise. Oh, well, let's try left. That might be the shifting left that I was trying to figure out how I could make it do it. I'm sort of jumping ahead of the instructions there, but let's try uploading that and we'll see exactly what left and right does. But I'm assuming it's going to be... now, this is... backwards is what you were just watching, which I would have thought would have been forwards. But maybe I've put that on the wrong way round, or I've lined that up with the other Acebot printing down the bottom there. So the controls are obviously meant to be at the back of it. Doesn't matter in the scheme of things, although it sort of does when I'm going to be using the apps controller. I need to sort of make sure it's pointing the right way. But yeah, we'll figure that out in a minute. Let's see. So this is left. So I'm thinking it's going to come towards me, but I could be wrong with that. So it's now uploaded. Let's turn that off. Let's flick it on. Yeah. Doing that way. So yeah, this is the back where the plugs and the switches are. Not doing what I would have thought it would have done, but it makes sense. It's just doing the same as it was doing forwards, but with alternate feet. So yeah, that does make sense to me. I'm going to finally, before I get back to instructions and things, I will upload the other control to it. The let's see about clockwise, which I'm sure is going to be somehow using the. It'll probably. It's going to be using alternate 2 again. It will rotate them, then lift it, and then put them back and drop it, and do the same on the alternate ones. I would have expected. Very useful that there are already programs set up to let you do that. Obviously, in there I've got network initialization. That must be the Wi-Fi bit. Move front, activate standby mode. Get forward signal, spider movement. Yeah, so that must be for picking up the communications and the controls, which is fine. I will be getting to that in a moment. But let's see, this should be clockwise, I believe. Anyone thought, oh, it's doing both. All 4 legs moving, lifting it up, and then spinning it around. Oh, you're not even watching that. Let me put it back on bench. There we go. Yeah, so it gets all four positioned. I like it. It's working very well. I'm very happy with how that's controlled. Clockwise, I won't bother doing because it will obviously be exactly the same, but the other way. So, yeah. Right, let me have a look through it ahead, see what's next, and show you what's what. So, just finishing uploading that, which is the expand program. Starts the program and forever runs this loop, although I assume the stand-on mode is just going to be sitting there forever. So repeating 3 times, move to the front, repeating twice, move to the back, and then activating standby mode. So that's now installed. So if I turn that off, forwards is that way. So it goes forwards, 1, 2, 3, and then it will go backwards, 1, 2, sit there and stand by. Oh, and then it breathes a bit and goes forward again. So it does loop it. Standby mode is only for 1 instance. It is in fact slightly rotating, probably because one or more of the feet is getting more traction than the others, and it's not sliding as smoothly as it should, or even it's not digging down a little bit deeper. But I'm not worried too much about that. Happy with that. It's coming off the edge now. Oh, you're not watching again. You're watching the wrong screen. Sorry, I forgot to switch it back. There we go. We'll watch it again. So it goes forward 3 steps, and then goes back 2, and then breathes for a minute, and then goes forward and 2. As I say, it is rotating anti-clockwise slightly. Might be due to the surface, might be due to the feet. I'm not entirely certain, but that's fine. In normal control, I'm going to be able to manipulate that a bit anyway. Let me just see the code. Let me change the code to push up rather than standby. Turn that back off there. We'll plug that back in. Forward again. It's a little bit deep in there for plugging that in, but that's okay. That's that. Let's connect that and upload again. So we'll see. I'll just change that, as I say, to push-up mode because I've not seen push-up mode before. It is useful that they do put these remarks in to tell you what it's doing, although so far it's been pretty easy to understand. But it's good that it's using the green bits are the robot exclusive commands, and then the repeats and things are part of the normal operations or normal control. Operations, I've got other things to programming language that I need to put in. My block, I don't know what that is, but there must be things that have been programmed in robot mode, Wi-Fi mode, and things that are all part of it as well. So let's go back now down to it and see what push-up mode is. So it's going to go forwards and backwards again. 1, 2, 3 forwards, 2 backwards, and then it will do a push-up. 3 push-ups. That's okay. Yeah, I quite like that. It's a little bit better than the breathing version. So there we go. That is that. We'll go back to the screen again and see next up. Right and left rotation. We've already done that. I'll turn left rather than rotating clockwise. It is just rotating clockwise. I've already jumped ahead doing that. Extending tasks. You've already seen how it moves left and right. Make it walk a square. Well, yeah, that would just be repeating 4 times. Go forwards, turn clockwise. It would depend on the clockwise. Yeah, the parameters of the program should be adjusted according to the actual operation effect. Depending on how it turns and how quickly it rotates, you might need to change the repeat a certain number of times. But that makes sense. Left and right movement, I'm not going to worry about that. Extending, what does this say? Say hello. So yeah, that was a greet thing. It's going to be waving a foot. That's okay. I don't need to do that either. Dance is just the dancing mode, which is going to make it do a dance. Again, don't need to see that. Dance steps. No, don't need to worry about that. Handsome as well. It's getting a bit more complicated. What's this serial port bit? The application of serial communications to control the robot dance, such as serial input. So that lets me pick it by the serial monitor. But no, Wi-Fi control. That's what I want. I've downloaded the app. I don't need to worry about that. I've seen that. Upload the program. Program control interface. Yes. So I need to download the robot Wi-Fi control program, which is section 8. I'll load that up. Connect to Wi-Fi. Let me get the program installed and see about installing it and getting it running. Right, I have uploaded the software. I've connected it to the Wi-Fi. This basically connects my phone directly to that. We'll turn the music off. We'll turn off the music button. Keep trying Wi-Fi. No, I'll just turn. Actually, there was a settings thing there. Let's turn that. There we go. Sound effects on. No music. Oh well. We'll just turn the sound off, shall we? Okay. So we're connecting to the robot music. When you push the connection button, it makes a jump. And then we've got direct control over the robot from an app. That's pretty cool. Nice. So we can make him lay down, sleep. Same as laying down, is it? Ends up to sleep, which is a little bit strange. Stand by is again the breathing one that we've had a little bit before. Okay, like that. Dancing we've seen. Oh no, we haven't seen. Very nice. Skiing. That's how I thought it was going to do the moving like that. Handsome. Yeah, we've seen handsome. Let's try fighting. Much the same. Greet will be the one where it waves at us. Yeah, that's okay. I understand that. That makes sense to me. So yes, that gives us app control. Now let me go back to the system and try and figure out exactly why that works like that. Let's have a look at this first and see. Bigger. Right. So this is all just going to be controlled by the app. So we've set it up. We know what we're talking about. We know what the password is. Spider network initializes the network. Yeah. Repeatedly obtain movement information. Spider movement. It's getting the movement and it's getting the forward signal, then move forward. If it gets the backward signal, move backwards. Yeah, so it's just a repeat to find out what mode it's got. So the handsome signal makes it do handsome, but you could equally make that do else. Push up wasn't one of the things, was it? Oh yes, it was. Push up is one of the things. Probably all of the things down there. So yeah, I understand that. It's just constantly searching and finding out what the signal is, and whatever signal it gets, it does the thing. That makes sense to me. I understand that. So that's all about connecting it. The app does. It's probably just going to be telling me about that. Oh, that's the end. That is it. That's the end of the video, the end of the build. Gyroscope control, movement of the robot through the smartphone's gyroscope. Try that, shall we? I'll push this one. Should be gyroscopically controlled. Wait, what? It does. It's doing the controls on there. And the rotation is not. It's gyroscope rather than rotation. So if I want it to go that way, I'll make it go that way. That's quite cool. Oh, I've knocked things over. Actually, I think it's. Is it backwards? No, it's not backwards. Something's not right because that's not quite how it. be going, is it? I put it the wrong way around. Stop turning. I don't know which way's which anymore, but yes. So it works. It does things. Yeah, I think I've got it. I don't know which way around, but yeah. So I now have an app-controlled spider robot with only 4 legs, half a spider robot technically. But yeah, that's quite good. I quite enjoyed that. Not much building going on, and unfortunate that it's missing its feet, but not too bad either. Yeah, that one is a little bit rough, so that might be why it's not turning quite as well as it should. But I like it. It's good. Very cool. I hope you've enjoyed the build. Do let me know in the comments what you think. I do have another project from Acebot to play around with as well over the coming weeks and months. So hopefully I'll have a grounding now in how the Ace programming software is called. What do they call it? It's called it Ace Code. Yeah, so I understand that. I'll continue to play around with it, but I like that it works according to the app. I don't know that the controls are quite set right. I might have played with something and made it go left when it says forwards or something. Sort of going that way now, isn't it? Not sure about that. Yeah, that's just a little bit strange. So, thank you for watching. I hope you've enjoyed it. Do let me know. And I shall see you for more very, very soon. Stay safe. Bye bye for now.